Welcome back to the CTO Playbook, the podcast dedicated to helping CTOs excel. I'm your host, Adam Horner. I coach CTOs from startups to enterprises, and I created the CTO Playbook platform to help strategic leaders in technology build their own leadership playbooks without having to start from scratch. One of the more common concepts I'm being asked to help CTOs unpick at the moment is something they can't quite name. It often arrives as an unease about velocity, about quality, about the growing gap between their seniors and their juniors. By the time we've traced it back, it lands in the same place. Do our boilerplates and starter code bases still earn their keep in an AI-accelerated world? When we get there, one camp wants to lock them down further. The other wants to delete half of them. They're both right. They're also both wrong. That tension is what I want to spend the next 20-odd minutes on, because the question of what to do with our boilerplate, our starter code base, the bit of structure our engineers copy whenever they begin something new, is actually a question about something much bigger. It's a question about how our teams think. It's a question about how the next generation of senior engineers in our businesses are going to be made. And it's a question about how much of our engineering judgment is now sitting inside files that were written 2 years ago and quietly forgotten about. Before we go any further, a quick word. If today's episode resonates and you're navigating this kind of transition in your own engineering organization, you can find more at thectoplaybook.com, including the early CTO map. That's a free 5-day email walkthrough of what most CTOs only learn the hard way. So let me start with a pattern I've been seeing in coaching conversations for the last 6 months or so. The shape is consistent enough that I'm fairly sure most CTOs listening will recognize it. The first signal is velocity. Dashboards look great, pull requests are landing faster than ever, story points, if your team still uses them, are looking healthy. By every visible measure, the engineering team is in good shape and objectively getting faster. The second signal is quieter. The most senior engineers, the ones who've been around the longest, the ones whose judgment we tend to trust the most, are starting to ask careful questions. Not necessarily loud ones, careful ones. Questions like, do we know why we chose this approach? Questions like, has anyone actually read this end to end? Questions like, if we had to onboard someone new into this service tomorrow, would they understand what it does and why? The third signal is quieter still. The junior engineers in our teams are getting confident faster than they're getting capable. They can ship. They can solve a defined problem when one's set in front of them. What they can't yet do is push back. They can't yet say, I don't think we should be building this at all. They can't yet say, this looks right, but it's going to be a maintenance nightmare in 6 months. They don't have the mental model to question the AI's output because they haven't yet built one of their own. That third signal is the one I want you to hold on to. By itself, it doesn't feel like a CTO problem. It feels like a hiring problem or a career development problem or just one of those things that will work itself out in the end. It isn't. It's a thing this episode is really about. But before we get there, we have to deal with the surface question, the one that's actually getting asked in coaching sessions. Should we be doing more with our boilerplate or less? In every conversation I have on this, two camps emerge. They're often inside the same engineering organization. They're sometimes inside the same person on different days of the week. The first camp says, lock it down. The boilerplate is the AI's only stable reference. It's the only thing keeping the AI from inventing new patterns every time it generates or hallucinates a new service. So load it up. More structure, more patterns, more opinionated defaults, more files telling the AI what good looks like in this code base. The second camp says, strip it back. AI can rebuild any plumbing we need in an afternoon. The boilerplate is bloat. It's a museum of decisions made before AI was useful, and most of it gets torn out at the start of every project anyway. So slim it down. Get rid of the stuff that doesn't earn its keep. Let the engineers and the AI build what they actually need. Worth noting here is that some engineers prefer to call the boilerplate a skeleton code base. Same idea, slightly bleaker naming, and one that often starts to feel more honest by the time half of it has been ripped out on the first contact with a real project. The deadness, after all, is already implied. But here's the thing. Both of these instincts are coming from real observations. They're both responding to something genuine. The first camp has watched what happens when AI is given too much freedom. It picks a database it should never have picked. It introduces a library nobody on the team has ever used. It writes its own naming conventions and its own folder structure and its own pattern for handling errors, none of which match what the team has previously agreed. So they want to constrain it. The second camp has watched what happens when the boilerplate gets too heavy. The first thing engineers do with a new service is delete half of it. Half of what's left turns out to be wrong for the specific job, and the structure gets in the way of the structure that actually wants to emerge. So they want to strip it back. They're both right. They're also both wrong. They're right about what they're seeing. They're wrong about what to do about it, because the question isn't how much boilerplate. The question is what our boilerplate is actually for now. And that question has a different answer than it had 2 or even 3 years ago. The metaphor that's helped me make most sense of this is construction scaffolding. All right, bear with me for a moment because it does most of the work for this rest of the episode. When a building is going up, the scaffolding does 2 jobs at once. It supports the building under construction, holding bits of it up while they're being put together, and it defines where the workers can stand. It restricts their movement. It gives them safe places to work from and the right tools within reach. The scaffolding shapes the building. The scaffolding also shapes the people building it. Different buildings need different scaffolding. Right? A tower needs one shape, a bridge needs another, and renovating an old roof needs a third. There's no universal scaffolding that fits every job. The boilerplate works the same way. It used to do one job. It helped the code. Now, it's doing 3. The first job is the one it has always done. It shapes the code. It sets our conventions, our default libraries, our folder structure, our error handling. That's the job everyone already knows about. The second job is newer. It shapes the AI. Every modern coding agent looks at the code base it's working in to decide what to write next. The boilerplate is the AI's first lesson in what good looks like. If we don't decide what that lesson is, the AI will figure it out for itself, and we may not love what it concludes. The third job is the one nobody talks about. It shapes what our engineers think about before they prompt. The presence of structure forces questions. Where does this service sit in our architecture? Is this a central service or a peripheral one? What level of error handling does this part of the system actually need? What conventions should this follow? If those questions are already answered by the boilerplate, they don't have to be answered every time by any engineer who might not yet know what to ask. So the boilerplate is no longer an efficiency tool. It's a judgment scaffold. Hold that phrase, because it's the central one of this episode. A judgment scaffold. Right? It shapes the code, it shapes the AI, and it shapes what our engineers learn to think about it. 3 jobs, 1 piece of structure, doing more leadership work than most of us have actually noticed. There's a second piece to this, though. And it's a bit that took me the longest to spot. But once you've seen it, you can't unsee it. There are 2 kinds of constraint operating on any AI-assisted engineering work. One sits inside the code. That's the scaffolding our code base already carries. Our boilerplate, our starter project, the conventions baked into the structure itself. The other sits outside the code. That's the context that we give the AI when we prompt it. The patterns, the rules, the examples, the architecture documents that we paste in. The conversation we have with it before it starts writing or coding. These 2 kinds of constraint are not independent. They're connected by an inverse relationship. The more technical constraint we put inside the scaffolding, the less contextual constraint that we need outside it. The less technical constraint we put inside the scaffolding, the more contextual constraint we need outside it. So again, because this is operational insight of today's episode, and it's the bit that a lot of teams miss. The more structure our code base carries by default, the less structure engineers and our AI have to reinvent every time they sit down to write something new. The less structure our code base carries, the more our engineers and AI have to put back every time by hand through prompts and conversations and decisions made in the moment. Now, what I've watched happen in well-functioning teams is that they've made a choice, deliberately or by accident, about where to put the structure. Some teams keep their code base very light and they invest heavily in the context. They have detailed prompts, rich architecture documents, strong patterns for how to brief the AI before any service gets built. Other teams keep the code base quite heavy, with strong opinionated defaults baked into it, and they keep their context light. The AI doesn't need much instruction because most of what it needs to know is already in the structure it's working with. Both can work. What doesn't work is leaving both light or both heavy. Because if we do that without realizing it, both light, then the AI invents the wheel every time. Both heavy, and we've over-constrained it to the point where it's burning tokens trying to thread the needle rather than actually doing the work. There's a dial, right? Most teams don't know they have one. They certainly don't know where they've set it. And this is the bit that I want to pay attention to because almost nobody is pricing it in yet. We have a generation of senior engineers in our businesses today who learned what they know by getting things wrong. They wrote bad code, watched it break, fixed it, did it again, watched it scale poorly, fixed that, did it again, watched it fail in production at 3 a.m, and learned. That process took years. It was painful. It was inefficient. And it was the entire mechanism by which senior engineering judgment was built. AI removes most of that pain, which is wonderful for the work. The bug gets caught at the right time instead of runtime. The bad pattern gets flagged in the pull request instead of in the post-mortem. The junior gets a working solution to their problem in 20 minutes instead of 2 days. And in the process, they lose out on the reps. There's no more repetition. They lose the banging their head against the wall hours that used to be how we learned what mattered and what didn't. They lose the experience of carrying a bug for a week and finally realizing it was something they assumed at the start. They lose the slow accumulation of, I've seen this go wrong before, and here's how it goes wrong. The bit that quietly turns a competent engineer into a senior one. Now, here's the part that most CTOs haven't yet sat with for long enough. Our most experienced engineers got their judgment from reps we can no longer easily reproduce. Our most junior engineers aren't getting those reps. And if we don't actively design replacements for them, because they're not coming back, in 3 or 4 years, we'll have a layer of very senior engineers retiring or moving on, sitting on top of a layer of engineers who can ship anything, but who haven't yet learned what's worth shipping. It's the COBOL problem all over again. The question that comes up in these coaching conversations, sometimes spoken, more often than not, is this: where do my future senior engineers come from if nobody is hiring or growing juniors the slow way anymore? I don't think there's a single answer to the question. I think it's one of the most important questions for our profession at the moment, though. And very few people are taking it seriously yet. But I do think one of the partial answers sits inside our scaffolding. Because the boilerplate in this new form is one of the few tools we have left to manufacture the right kind of friction at the right moment. The right kind of friction has nothing to do with looking up libraries or remembering syntax, because AI handles those just fine. The right kind of friction is the friction of asking, what does this service have to be good at? Who is its user? What can go wrong? And what should happen when it does? What does done actually look like for this piece of work? Those are the questions that when an engineer is forced to answer them before any code gets written, build the mental model that one day makes them a senior. This isn't overhead. It's how seniors get built. Now let me pause here for a moment before we go into the playbook. Because if you're listening while walking or commuting or between meetings, just hold this question. Otherwise, I encourage you to write down an answer for yourself to this. When your most junior engineers start something new in your code base today, which questions are they being forced to answer before they prompt the AI? Not after, not in review, before. If the answer is, I'm not sure, or none really, then the rest of this episode is exactly for you. So let's make this practical. Here's the playbook. 5 steps. None of them are technical. All of them are about how we choose to structure the conversation between our engineers, our AI, and our code base. Step 1, decide your boilerplate taxonomy. Not all of our services have the same job. The service that sits at the heart of our platform, the one that everybody else relies on, has a very different set of responsibilities from the service that sits on the edge of the platform talking to some flaky third-party API. One needs to be small, fast, and trusted. The other needs to be defensive, resilient, and full of safety nets. The scaffolding for one is not the same scaffolding for the other. We probably don't want one boilerplate. We probably want 2 or 3. And the choice of which boilerplate a new service starts from is itself a meaningful decision. It tells the AI what kind of service this is going to be. It tells the engineer what kind of questions they need to answer. That choice is part of the scaffolding. Step 2, set the dual constraint dial deliberately. Now that we've decided the shape of our boilerplate or boilerplates, we have to decide where on the dial we sit. How much of the scaffolding lives inside the code itself, and how much lives in the context that we give the AI. There isn't a single right answer to this one. It depends on how stable our patterns are, how often they change, how senior our team is, how much variation we want to allow between services. But it is a decision. Make it once, write it down, and review it deliberately. The teams that get this right know exactly where their dial is set and why. Step 3, build a pre-flight checklist. Right, this is the gate, the decision gate. Before any non-trivial piece of work begins, before the AI gets the first prompt, before a single line of code gets written, our engineers go through a short, structured set of questions. This is not a 50-question bureaucratic checklist. This is 5 to 7 bullet point questions that capture the things we can't afford to get wrong. Borrow the language from aviation, right? Pilots run a pre-flight checklist before every flight, including the routine ones, including the ones they've done 1,000 times, because the cost of forgetting is just too high. Our engineers should be doing the same thing. What goes on the checklist depends on the business. Most of the ones I help design touch on the same 5 areas. So very briefly, architecture. Where does this fit and what's it relying on? Payments and money. Is there anything that touches financial flow here? And if so, what controls do we need? Security. What data does this handle and who has access to it? Reputation. What happens if this breaks publicly and is anyone watching? Timeliness. When does this have to be done and what gets cut if we're late? Every team will have its own list. The point isn't the specific questions. The point is that the questions get asked every time by every engineer before the AI does a thing. Step 4 on the playlist then. Make the gate teachable. Don't stop at enforceable. And here's where most teams stop too early. They write the checklist, they enforce it through pull request templates, and they think they're done. They're not done. The checklist is the artifact. The teachable bit is why each question is on the list and what a good answer looks like. Use the checklist in code reviews. Use it in one-to-ones. Use it in pairing sessions. When a senior engineer reviews a junior's work, the conversation isn't, did you fill in the checklist? The conversation is, talk me through your answers. The junior learns what good judgment looks like by being asked to articulate their thinking before the code went anywhere. That conversation is the replacement for the friction we used to get from doing it wrong. It's slower than letting AI do everything, but it's vastly faster than waiting for engineers to learn through years of production failures, and it's the bit we really should not be skipping. Step 5, treat the boilerplate as living infrastructure. Boilerplates used to be set up once and forgotten. There were some teams I used to call it a walking skeleton, dead by definition. That doesn't work anymore. The models are getting better every quarter. The patterns that worked 6 months ago are sometimes wrong now. The shape of what good looks like is moving, sometimes quite quickly. So put a recurring review on the calendar, once a quarter, once a month. Get a small group of senior engineers in a room and look at the scaffolding. What's in there that the AI now handles fine on its own, so we can take it out? What's missing now that the AI is doing things we didn't expect it to do? What's a pattern we've seen emerging in 3 or 4 services that should now be promoted into the scaffolding itself? This isn't a big piece of work. It's a small, consistent piece of work, and it's the one that keeps the scaffolding alive instead of letting it slowly decay until somebody on the team decides it just has to go. So let's pull this all together. The question engineers across our businesses are quietly arguing about whether to lock the boilerplate down or strip it back is the wrong question. The boilerplate isn't an efficiency tool anymore. It's a judgment scaffold. It's doing 3 jobs at once: shaping the code, shaping the AI, and shaping what our engineers think about before they prompt. There's a dial, technical constraint inside the code base, contextual constraint outside it. The more of one, the less we need of the other. Most teams haven't yet noticed they have the dial. The good ones have set it deliberately and know why. And then there's the bit that almost nobody's talking about yet. The reps that used to make seniors out of juniors are disappearing. AI has taken away a lot of the friction that used to be the school. If we don't design replacements for that friction, we'll wake up in a few years' time with a senior shortage and no good explanation for how it happened. Our scaffolding and our pre-flight checklist that sits in front of it are some of the most powerful tools we have to engineer that friction back in deliberately at the right moment. If this is one of the conversations happening quietly in your engineering organization right now, and you'd like a thinking partner for the work of redesigning what your boilerplates and your gates need to do next, that's exactly the kind of work I help with through the CTO Playbook. You can find more of this on the ctoplaybook.com. Have a look at the early CTO map while you're there. It's 5 days of email, and it walks you through some of the patterns most CTOs only learn the hard way. Until next time, keep leading with clarity. Thank you for listening to the whole episode. I appreciate your time. So just before you go, I'd like to ask you for a favor in return for putting together this episode of the CTO Playbook for you. Please share the episode with just one person who will appreciate it. Wherever you're listening, whether that is Apple Podcasts, Spotify, Amazon Music, or another platform, sharing the episode will help more CTOs find the podcast and enable me to create more great content. Remember that you can find more information on the CTOplaybook.com. Thank you for listening, and I'll see you on the next episode of the CTO Playbook.